and we'll continue that one also. So different networking devices like hubs, repeaters, switches, routers, modems, firewalls. Okay, different devices are there. So each device has different purposes kind of stuff. Here, some of the devices we are going to discuss very things. Okay, first one is hub, and here is simple way. I'm not talking in a full mode like So first one is like a simple one or two lines, one or two lines wise, and we'll tell. Then we will just explain each one. Little additional points. Hub is a device used for small networks and LAN communication purpose. LAN communication, small network, 2, 3 computers are there. Hub is enough. Okay. Next to it device is repeater. Repeater is repeat the signal. It means normal our we are using STP or UTP cables. You know the cable range is 100 meters, but I have to connect long distance, little long distance, not very long distance, little long distance. In a building, I have to connect. So signal become weak after 80 meters almost, and 100 meters almost dead weak. So what we need a repeater. Repeater repeat the signal. Weak signal again it will repeat. It not boosting actually repeat the signal. So longer the communication you can. Switch. Hub and switches both are for LAN communication. But hub is for small network. Switch is for both small and large networks. We can use it. Like you have a 20 computers, 30 computers, 40 computers. Switches we can use it. Switches having an additional feature called a MAC learning features. Bridges. Actually, bridges are not exactly a devices. It is software based things on it. Or different topologies you want to connect, we need a bridge. That to a server like that we use. Next one is router. The router is used for both LAN communication and WAN communication. Router is a inter-networking device. Routers knows how to reach the destination. Guys, within our private LAN, we have a switch or a hub to communicate. But when you want to communicate outside of the network, when you want to communicate outside of the network, so what we need a router, inter-networking device. So we are communicating to google.com, facebook.com, youtube.com. Okay. So we are communicating. So outside there is different places, those servers are there. How can we able to reach? Through the internet. In this internet, there's several routers are there. Okay. These routers will tell you where how to reach the destination in a best way, best path. Modem, modulator, demodulator. Already we know what is a modem. Use it to connect internet via ISP. So you have to connect your network to ISP. We need a modem using telephone cable or a fiber optical cables. Okay, these are the quick points about devices. Here it is, hub. Hub is a non-intelligent device. The hub is look like that one. You can see there is a box with certain ports. So you can connect devices, means your laptop or desktop, with a wire to this hub. Hub is non-intelligent, means there is no separate processing related. Simple wire switching is there. Okay, not understand MAC address or IP address. Hub is an example for layer 1 device, means physical layer as per the OSI model. OSI model having 7 layers. So hub is a layer 1 type of device because in a layer 1 there is no MAC address, IP address kind of concepts. Suitable for small networks, used for LAN communication. The switch, the hub is having a property called broadcasting packets to every network. Here it is. I put my switch box as very big one. So usually you should draw it very small one. So I have a ports are there. Port number 1, for example. Okay. So like this, we have a ports. Port number, for example, you put a 1, 2, this is 3, 4, 5, 6, 7, 8. Of course, these are not required ports also. Okay. So this is device A, B, C, D, E. So how it is communicate? So A to B communication. For example, A want to send a packet to B, and this is our hub. So packet will send to the port number 1, and same packet is sent to port number 2, port number 3, port number 4, port number 5, and port number 6, kind of stuff. Of course, not connected devices, anyway, it is not forward. So packet is reached to DPC, EPC, FPC, CPC, and DPC also. These are all received same packet. Okay. So without knowing what is the exact destination, what is how our hub is doing, it will forward the packet. Of course, at a destination, so it will understand whose packet it is. So what it will do, it discard the packet. C, E, F, D, these packet, these devices will drop the packet, and B accept the packet. But unnecessarily, the packet is sent to other devices. This is one point. Similarly, think like this, C to D communication. C send a packet to hub. Hub is send that packet to every device in the network connected. So what happened? So how much of traffic is generated in a hub? Because of this parallel communication, okay, and unnecessary packets also traveling. So possible collisions will occur, packet collisions will occur. Okay, so packet collisions occur, packet damages, and packet has to be resent again. More collisions will occur. So that's why we are telling this hub is not suitable for a large networks. It is suitable for a small networks. So hub is, it's a broadcast packet to every device in the network. Not only one time, guys, multiple times. So A send a packet to B. Okay. So A send packet to hub, hub to B, C, D, E, F. Okay. B accept the packet, D, E, C, D drop the packet. Because of this, parallelly, similarly, so many other packets are traveling in the same hub. So number of collisions will occur that lead to packet data loss. Guys, understand hub?
Yes.
Guys, understand what is hub? How it is function? Just only put hub and try any GIF. This is send a packet here, and the same packet is sent to everyone. That is hub. Okay. Yes. Correct. Next is repeater. What is a repeater? Repeater repeat the signal again so that you can send a signal to long distances. Sometimes in some places they use hub as a repeater. Some places they use hub as a repeater also. This is a repeater. This is hub. Okay. Hub, repeater. It is. So when you are communicating for a long distance, it is a little long distance. So what will happen? Data signal become weaker. What is this repeater will do? It repeats the signal so you can able to communicate long distance. Means little longer distance. Of course, we in a generally we cannot see these repeaters, but we can see this Wi-Fi extenders. The best example for Wi-Fi repeater is Wi-Fi extenders. What is this Wi-Fi extenders? See this picture. So there is an internet from outside to my Wi-Fi router. I'm in the same room, so I'm getting a very good signal. But if I'm in a different room, so little longer distance is there. Okay, so I'm in a different floor. Means like it's a duplex building kind of stuff. Okay, I cannot reach. For example, I'm in an office. It is a large room, and there is a separate room is also there. Okay, and there is a large room and as well as separate room and separate cabins are there. So I cannot get a Wi-Fi signal in every corner. Okay, every room I cannot get it. In a normal home we can get it, but if you have a multiple rooms and a long distance, there is a distance from your Wi-Fi router. Okay, so what we are using? We are using this Wi-Fi extender. So what is the use of this Wi-Fi extender? So we'll keep this Wi-Fi extender from as okay. So any diagrammatic, so that is a good thing. So these are our Wi-Fi extenders. You can connect with the LAN cables also. Okay. Of course, guys, remember
How many meters on average it can extend?
how many?
On an average, how many meters it can extend, sir? Like for a router, how many meters?
Depends upon your Wi-Fi
Room to
router.
room only, sir.
It depends upon your Wi-Fi router. Normally, I put a Wi-Fi router here. So the range coverage of Wi-Fi router is, for example, up to here. Okay, so for example, my device is here and my other device is here. For example, I'm not meter wise, I cannot able to give details. You can check any Wi-Fi routers, their range. Okay, it means the surrounding range. The range is not in a direct. So radius wise, you have to take it. And other things like a glass doors. Glass doors also prevents, right? Walls prevent the signals. Open air, somewhat we can get it, but some few things will cannot receive. So for here, I'm getting a good signal. So at least I'm getting a signal. For here, I'm getting very weak signal. Okay, or no signal at all. So what I have to do? I need a repeater where I'm getting a better signal. Okay, this is where I'm getting good signal. From here to here, distance is reduced. No, so this is from here to here. distance and compare from here to here is a distance. So what is this Wi-Fi extender will do it? It receive a signal from here and it will send a signal to here. So I will get a more better quality signal. And of course, guys, when you are connecting to my Wi-Fi router, so this is my Wi-Fi router. For example, name is router name is SSID is for example S1. My SSID is S1, and there is a password. I want to connect it to this one. I put a S1. So find here, find out SSID here, click it, put the password. So what to whom I am connecting? To this router. Okay. Now come to this place. Here I want to search signal, and I am going to this search SSID. Which one I have to put it? S1 only. Password also S1 password. Not this one. This one only. Original Wi-Fi router only we are connecting. This is just a buffering type. Means we are not getting because we sit in some different room or longer distance from our actual Wi-Fi router. So you are not in the range. So you put install a Wi-Fi extender. Wi-Fi extender is just repeating the signal wireless. Okay. Actually, you are connected to original Wi-Fi router on the SSID is right. So people will install in different places in different ways. Okay. So you can also try that one. Check it. Okay. So this is repeated. Next one is switch. What is a switch? Coming to hub and switches. Switch is also used in LAN communication. Hub in switches, both are LAN communication. Hub, small networks, switch, small network as well as large networks. Switch is intelligent device, meaning inside of this switch device, there is a processor, RAM kind of stuff, and some operation algorithms are there. Understand MAC address. Switch can understand MAC address of the devices. It maintains the MAC address table, and it is an example for layer 2 device as per OS layer called it DataLink Layer. Okay, large number of devices we can connect to the switches. Okay, it can able to handle. Switch initially work like a hub. What is the hub functionality? So you have a hub. Okay, you have a devices. You are connected to this or device, right? Okay, so our switch having a port with a specific port number. Of course, as a hub is also having a port with a specific port number. So this is a port number 1, port number 2, port number 3, port number 4, 5, 6, 7, 8. Okay, now this is switch. Okay, so how it is once again. I try to communicate from A to B. Initially, it is like a what we can say hub only to broadcast. A send a packet to switch port 1. Look at here, MAC address table or MAT. Okay, so what will happen here? The switch port and MAC address. This is a port number 1. So when it is received a packet, it understand MAC address, source MAC address of a packet. Okay, so source MAC address is belongs to A. It is A's MAC address. So it will assign like this. Inside your switch, there is a table, port and MAC address. Port number 1 is connected to A's MAC address, depends upon the packet it is received. Second, what is the source? A. What is the destination? B. So as per this current MAC address, where is the B's MAC address? It is not there. It is not there. So what it will do? In this MAC address table, B's MAC address is not there. It will send to everyone, those who are connected to this switch, because I don't know the destination. I have to ask everyone. So again, what will happen? B accept the packet, C drop the packet, D drop the packet, E drop the packet, F drop the packet. This is how it is communicated. And next one, for example, C is trying to communicate it to E. C send a packet, the port number 5. This is port number 5. Okay, so what is our switches will do? Port number 5 is what is the incoming packet? C MAC address. Is MAC address. Okay, then it has to go to somewhere, right? It has to go. It does not know is MAC address, which port number, where is the E device is connected as per the MAC table currently. Then it is sending to everyone. Of course, E accept the packet, remaining drop the packet. Last example, guys, look at here. Now, D is trying to communicate to A. D is trying to communicate A. D send a packet to the port number 2. This is port number 2. Okay. So what is our switch will do? Immediately it will learn the packet. Port number 2 is connected to DPC and this is D's MAC address. Okay. Next. Where it has to be reached? A. What is A's MAC address and where it is pointed? Port number 1. The packet will send to this port number 1 and A received a packet. It does not do broadcasting. So when devices are communicating, there is a source address, destination address. The switch will, whenever it is received a packet to a port, it take that MAC address assigned to that port number in the MAC address table. When devices are communicating, so it will observe their MAC address, source MAC address and destination MAC address. So it will find the list, the destination MAC address list here, and it will do it. So for example, port number 3 is connected B's MAC address. Port number 4 is connected to EPC and E's MAC address. Now, if they are when they are communicating each other, it become more easier. So port number 6, sorry, F MAC address. So our switch will create a MAC address table as per the requirement. Again, we will once again, guys, I have a MAC address table. While devices are communicating each other, switch observe the MAC address from the device address and put it in, it maps to the switch port number to that device MAC address. Okay, it will create a MAC address table. What is the advantage? Even though it is initially broadcast like a hub, later it is become unicast. For example, now we want to communicate to F device. We send a packet to 2. Okay, good. And where is the F? This is F. Which port? 6th port. It will give it to the 6th port, 6th port to F device. Direct communication. Not required to do the broadcasting. That is the main difference between hub and switches. Switch initially broadcast send packet to everyone like a hub. Switch verify the MAC address table against for a destination MAC address mapped port number. If it is finds packet sent to the port. If it is finds packet sent to that port means later unicast. Here the entire process also I have written. Please you can read it. Guys, understand the process? MAC address learning and all. MAC.
Could you explain with other examples, sir? I didn't understand it actually.
Very good. So I'll remove and I'll put it once again. Simple. Hub is always broadcast. Switch. It will learn the MAC addresses. Initially, it will broadcast. Later, it will do unicast. Okay. Simple. When normal example. If you need a normal example, I can simple. First day of your college or first day in your job. People will tell some names, but actually you don't know. Right? We don't know all the names and their places, right? So you have to go to a specific place. There is a one team leader is there. In this chair is belongs to someone. Initially, we don't know. So what we will do? We'll search it. And remember the location of each person. Okay? Location of each person. Next time we will do it. We won't search for every person, right? Every seat, every corner, every room. We don't search it. We'll directly go and get it, right? So it is like that only. Switch, but it will take time to show the practical part.
No, no.
Okay, so practically you can also see how it is creating MAC address because the new versions asking authentication compulsory. Anyway, we see. Guys, are you available tomorrow morning?
Yes, sir.
Okay. So I will inform. So if it is no, not this one. That is wrong. Okay, you want to learn how to use this packet tracer and all, guys. There is a beautiful course. 3 courses are available. I think I have told you that is skills for all. Okay, this is simple website. You can learn so many things with this kind of stuff. You can see, you can learn networking related, voice something, voice hardware related, data science related, programming related, okay, IoT related, cyber security related also. And you can also specifically learn how to use this um, packet tracer kind of stuff also there. Somewhere it is there, but you have to check it. And I log in with that account. And I have two accounts. One is NetTicket account and this one. So this is a switch, okay, and I have a computers. Okay. Always use straight cable because PC to system, this is straight. Okay. So originally, geographically it is little different. But so there are some systems are connected. Again, if you have a computer means you need an IP address to communicate. Default gateway is not much required, just it is a LAN. LAN is required only IP address and subnet mask. So I put a 10 series to make it myself more easy communication. I'm copying this part, put it in other systems. Yeah, I can have a DHCP server. That one also I will show you. Okay. Here I'm configuring manually. So what is the problem in a manual configuration? Possible wrong entries. If more systems, difficult to assign and administrate. Understand? So it is already assigned someone throwing in error. Okay. So possible conflicts, possible wrong IP address. Another one is more number of devices, difficult to enter. That is a manual thing, but it is static. It automatically never changes. So guys, I assign an IP address to everyone. This is my switch. It is a little small text. Okay, so show MAC address table. This is already you can see port number 5, port number 6 having a some communication automatically. So their MAC address. Port number 5. I think this is port number 5. This is 6. Okay. So go to command prompt. Okay. I read config. So this is the MAC address of PC5. IP address is 16. Port number 6. Ticket port number 6. 60030 F2 9A A2 45. So it is Okay, don't worry. Just for example, this is first PC, right? Here it is. I'm trying to communicate 10 dot. So what is my IP address? IP config. So IP config. I'm typing wrong. Yeah. Mine is 11. And what is my MAC address? IP config dash R. So what is my MAC address? 00E0F9A6 like this, right? So what I'm trying to do is I'm trying to ping to some other system 10.0.0.12. So I got a reply from my destination PC. I'm trying to communicate it from 12. This is the 12th PC. This is 12. Okay. So I communicate. I send a packet from here to here. Okay. So communication is good. How I know? Reply from 10.0.0.12. Communication is good. Now again, I'm trying to show you the MAC address table in the my switch. Can you see? Port number 1, MAC address. This is our PC, the first piece. And this is port number 3, that PC MAC address. Means when they are communicating each other, what is our switch is doing? It note down their MAC addresses against the switch port number. So once these all are communicate each other, once every device is communicating each other, so it will have a list of port numbers with respect to device MAC addresses. Whose MAC address is this? PC MAC address. Whose port number is this? Switch port number. Okay, it will learn dynamically and it will keep it like. Of course, this is also used for security purpose. Now it is only MAC learning MAC address. But if you go to the switch security, this is also more helpful. The concept is more helpful. Guys, understand now? So how switch is learning the MAC address and the port numbers are look like. Anyone? Guys? What happened, guys?
Sir, yes, sir, audible, sir.
Audible, right? Good.
Yes, sir.
Number of collisions are less, number of packet loss will be reduced. So why? Because of initially it is do the broadcast, but later on days unicast means not required to send packet to everyone all time. Okay. So works with the floating, unicast, cut through switches, store forward switches also there. Again, guys, switch is a L2 device as per Cisco. Sorry, as per YSL layer 2 device is a data link layer. Some will ask question, maybe in future. So you said layer 2 switch is layer 2. But they said like it, there layer 3 switch is also there. Yes, there is a layer 3 switch is also there. But the purpose of layer 3 switch is little different from normal switch. Okay, it's not like that. So layer 3 switch works with MAC address and as well as IP address. Okay, it function like a router, it function like a switch also. But for internal communication only, it does not have one port. It does not have WAN. Not for WAN communication. Not for WAN communication. Because it is does not contain serial port. Okay. Not for WAN communication. I don't want to give more details. Okay. So L3 switches for a BTP communication, virtual terminal protocol, something is there. Okay. VLAN, inter-VLAN communication, VTP, VLAN terminal protocol. So I forget that one. So one second. VLAN, VTP, STP, things are there. Yeah, VLAN trunk protocol, correct only. VLAN trunk protocol, VTP. VLAN virtual LAN, inter-VLAN, inter-network communications, basic internal communications only. Okay. To act like a router and switch, it works with an IP address, MAC address, VTP, inter-VLAN routing, kind of stuff we can do with the L3 switches. Simple, I kept a L2 switch. This is L2 switch, but in switches, we have a L3 switches also. Okay, this is L3 switch. Okay, yeah, this is how it is look like. The same, look like same, but we can do some other protocols. See? This is L2 switch. So how, this is also so look like same. No difference. You don't. By the number, by the internal configurations, it is there. So you can see multi-layer switch. You can easily understand this is multi-layer switch. Multi-layer switch means L3 switches. Okay. So this is the guys. Next one is router. What is a router? Router is a inter-networking device. When you are communicating between different networks, different physical or logical networks, we need a router. See in this diagram, so this is a one network, this is another network. To make a communication between different networks, what do they use? They use a router. Router works with a logical addressing, not with a MAC address. It works with a IP address, logical addressing. What is the purpose of router? To connect to our more networks because inter-networking device. We use a router for both LAN communication and a WAN communication. Router works in a layer 3. Okay. OSA layer, layer 3 network layer. So here I put a one diagram, different routers in their local networks. So first one is Hyderabad network, next one is Pune network, other one is New Jersey. All are connected via WAN connectivity. Local network, LAN network, but outside WAN connectivity. Guys, in the globally, there is a lot of routers are connected each other. You are communicating from your system to me. We are communicating each other between. There is a lot of routers are there. So we are all communicating via those routers only. Okay. Sometimes it is very difficult to judge a path. You know, simple to say. These routers are connected different ways. Okay. These are globally, so many routers are there. All are connected in different paths, different ways. But I want to reach from point A to somewhere in a point B, which is the best path based on the connectivity. So who will tell? Again, router only. Actually, it is not router, it is route. Router. You should spell like a router only. But people become habituated to say router because its route is used best way to tell this is a specific kind of stuff, not a general kind of stuff. What is route? Path. What is router will do? Shows best path to reach the destination. Routers use routing tables. In these routers, they have a routing tables. The routing tables tells how to reach the destination. These routing tables tells how to reach the destination. I try to open some my pre-configured kind of stuff. What happened? I try to open this. Do you want to see your network? Okay, no. Okay. This is dynamic routing protocol. Huh? No, 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 no. No. See this? So here I configured a network. This is another network. This is another network. This other networks are not there. Different offices. This is one office, another office, another office. They are connected through WAN connectivity. They have to communicate from one place to another place. For example, I open this router. I want to see so routing table. So routing table only, right? So it's not showing any. So show route. I will put a show route. Yeah. Show IP route. See this? What are the different networks are in this network and how to reach the destination? I need only one part. So some are connected directly, some are locally connected. Okay, some are remotely connected. See this? This is a network. This is a network. This is a network. So from this router, how it will be reach this particular network. Okay, so for example, this network, this particular network, how it will go? It will go like this. Means it has to go like this and like this to reach this destination. Okay, from here, I want to reach here. So packet has to go like this, like this, like this, and like this and go. Okay, so depends upon how it is connected. Everything I use same example only. That's the same diagram. Different places. I want to reach from here to here. I can go directly from here to here. Okay. So whatsoever it is, it contains a routing table. Based on the routing table, so router will tell which is the best path. But how these routing tables are created? It can be created statically. So manually you can tell how to reach the destination. Manually can tell. So this is the way you have to reach the destination. If this particular network you want to reach, go like this. Okay. You want to reach railway station. You have to go to this side. You have to go to the bus station. You have to go to this side. Like that. The routing table also will tell you want to reach this kind of network. Go to this side. Routing tables are created by automatically by using routing protocols called dynamic routing protocols. Okay, there are different dynamic routing protocols are there. So RIP, EIGRP, OSPF, PGP, IS like this. These are the dynamic routing protocols are used to create these routing tables automatically. If you enable these, if you enable these protocols inside your router, automatically routing table will be created. Again, guys, what is the router? Inter-networking device. It connects to our more networks used in LAN and WAN communication. L3, layer 3 device network layer works with logical addressing, IP address. Router shows best path to reach the destination. Okay. It uses routing tables to know how to reach the destination. Okay. These routing tables are created statically or dynamically. Statically means manually you have to create it, or use certain protocol, dynamic routing protocols to create these routing tables. Guys, understand up to router? The last part is only modem. Okay. For today,
Yes, sir.
what is the modem? Already we know what is the modem. Modem is modulator and demodulator. Your our network signal means inside your home or inside your office, we are all communicating each other in the LAN. The entire signal type is a digital signal, normal digital signal, computer-based signals only we are using to communicate. But you have to communicate outside of your network, long distance communication, right? So internet you want to access. So the long communications are analog signals, either telephone signals or a fiber optical signal, but there are analog signals. What is your modem is doing? It converts your digital signal to analog, analog to digital. This is one point. And very important point is your what is the purpose of this modem is to make you connect to your ISP to get internet. In a modem, we configure your connection type, username and password. So once connection is established to ISP, it will tell your username and password. So ISP verify your username and password. Once it is authenticated, it confirms your connection. So you will get an internet. We are using our Wi-Fi routers. Some Wi-Fi routers having built-in modems. So that is our modem part. So these are hub, switch, router, and finally a modem. Okay. And small differences. Hub used for LAN communication, small network, broadcast. Always packets are broadcast. You have to communicate from one device to another device, but same packet will send to all other connected devices. Switch. Switch is also for LAN communication and small to large networks, MAC address learning, MAC address table. Switch is initially do the broadcast, but it learn the MAC addresses, connected devices, MAC addresses mapped to the switch port number, created a MAC address table. Then it is used unicast to communicate. The number of collisions will be reduced. Okay, number of collisions will reduce, the packet data loss is less. That's why it is suitable for both small and large networks. And hub is a layer 1, which is layer 2. Next one is layer 3 switches also there, which is special type of switches used for both LAN and LAN communication only, but inter-VLAN routing, BTP configuration, it is more helpful. Another one is router. So router is layer 3. Router is layer 3. It works with logical address. Router shows best path to reach destination. How? It contains the routing tables. Either it is created manually or dynamically by using dynamic routing protocols. So in your WAN communication and LAN communication also, router is more important. Inside LAN, you need a router. When you want to communicate outside of the your LAN, so we need a router. So router is a inter-networking device, network layer operation device it is. Finally, modem. Modem not comes under any of these things, guys. Modem is exactly layer 3 type only, but modem is a device basically to convert your analog signal to digital signal, which is used to connect your network to the ISP to get internet using telephone cable or fiber optical cables. Okay, so that is the one small part is called firewall. Firewall device is also there. What is the use of this firewall? Firewall used to protect your network. If you have an office and you have a firewall device here, what is the use of this firewall? So when you got internet from outside to inside, packets are getting, right? So it filters the packets in different levels. Means MAC level, IP address, network address, protocols, port numbers, application type. So it will filters. It controls both incoming and outgoing traffic. So, okay. In generally, firewalls does not mind your outgoing. Outgoing is always from inside to outside, always green signal. But outside to inside, there is always a security guard. Okay. So your firewall will agrees particular network, so it can able to come inside. Okay. So that is a firewall. Firewall is used to protect your network from attacks, generally through network attacks like firewalls, from IP related, port number related attacks. So it allows only a specific set of networks. Okay, certain number of type of ports, applications access, service access allowed in the firewall. Okay, what is a firewall? And some firewalls having a feature with a VPN. So you want to connect VPN type of site-to-site VPN configuration you need it. So certain firewalls having a built-in feature called a VPN feature. Okay. So VPN story is a big story. So I'm trying to say. And I already kept some of the details like what is a ping command, what is a trace RT command. Okay. And some are the troubleshooting things. I kept it. Just I will give you a quick review and tomorrow I will explain once again about troubleshooting. What is a ping command? Ping command is used to test connectivity between the devices. See, A to B communication is there or not. I want to test it. I use a ping command. At A, I want to know can I reach B or not. So what I have put a ping destination IP address. Okay. Destination IP address. You want to test, are you able to communicate from your system to other system? You should know other system IP address and use the ping command. So then if you got a reply from the destination, okay, reply from the destination address, it means good communication. Okay. So that's the point I'm trying to say. So I think I have given like reply from destination IP means communication is good. If you got destination host unreachable, if you got destination host unreachable like this, and you got a reply from your own PC IP address, and you got a destination host unreachable, means there is a problem. Where it is destination device is down, or you entered a wrong IP address, a destination device is disconnected. Reply from destination device, good. Reply from your own device and it is showing destination host not reachable, means either you enter wrong IP address or maybe the device is not available a device is disconnected. If you get a reply as request timed out, it is the destination device firewall block. The firewall, the destination device firewall is blocked. Block your connection means you are able to reach up to the destination. That firewall is not allow you. The firewall of the device is not allow you. Sometimes path is not available. You're trying to connect, but the further path is not available. Wrong IP address. Okay, or maybe the real path is not available, or maybe path is very far away from your unreachable network. It is maybe destination system down, wrong IP address, disconnection also possible. Okay, so these are the ping related troubleshooting. You ping to the destination IP address, you got a reply from destination IP with the destination IP. It is good. This is good communication. You can see zero packet loss means ping is good, communication is clear. Destination host not reachable. I ping to this 100, but I got this one. Meaning is, so I'm getting a reply from my own device IP address, host not reachable means, so either device is down, wrong IP address, or maybe device is disconnected. You got a request timed out. It means mostly the device is available, but the device firewall is not accepting your request, rejecting your request. And maybe the device is not available. Maybe your wrong IP address. Maybe the path of your IP address is not clear. Okay, so that is about your ping. Just I will tell this Tracert and we'll close today. Tracert tells how to reach the destination. You are in a place. Now I want to reach where is the google.com, right? So if I do ping to google.com, I'm pinging to www.google.com. I ping www.google.com. What I'm getting? Reply from google.com IP address. So this is telling I am able to reach destination. From my system to destination, communication is there because of this reply, because of this command. I know destination, I can able to reach destination or not. Tracert will tell how you reach the destination. From your system to the destination, there is several routers, switches, networks are there. So you will get it like this. Okay. So first it starts with my own default gateway. Example, my router to my what we can say ISP router to other routers, other routers. Finally, I reach the destination. This is the way. These many routers I cross to reach the destination. For example, you are in your hometown. You have to come to Hyderabad. You get in a train or a bus or a car. So what you will tell how you came? Directly, we cannot come in a one single shot, right? We will be to via Guntur, via Vijayawada, via like this. These are stations I cross and finally I reach the destination, right? So I'm in Visakhapatnam, so I want to reach Hyderabad. So how many stations I have to cross? I have to cross this Rajahmundry, Samalakota, like Vijayawada, Guntur. So like that, it is there is several stops are there. So we have to cross it, right? So I have to reach Delhi. So there is some stations are there. So whatever the path you have to destination, maximum number of 30 options means 30 routers, you have to reach the destination. Otherwise, packet will be dropped. Okay. So what is ping? Ping command will tell you, can you able to communicate to the destination or not? Ping command is used to test connectivity between devices. Remember these points. Okay. So we ping to destination depends upon your reply. You understand what is the how the communication is going. Tracert. Tracert will tell you how you reach the destination, the path it will show. Okay, guys, up to here we discuss. So possible, I will tell tomorrow morning only if anybody able to join. Otherwise, we'll continue on Monday. Okay, because my train timings and all, so I have to check it. Because there is some few things like IP addresses, OSA layers completed, then we can discuss happily troubleshooting of network. Only few topics will be left. Otherwise, yeah, we'll see. We're looking forward to tomorrow. Okay. If any problem occurs, then I will inform you again. So mostly I have a class tomorrow. So I will confirm by tomorrow morning or evening, at least today evening or tomorrow. Guys, understand up to here what we discussed? Now stop recording.